Okay, here we go. This is going to be our introduction to multiplying polynomials. So multiplying polynomials. And today is the 29th. Okay, so far we've done adding and subtracting polynomials and then like classifying polynomials. The adding and subtracting polynomials should have felt good. Like we should have been confident with it because it's basically combining like terms, which we know how to do. Okay, this is going to be the start of new content. So this is stuff that you haven't seen before. There are going to be a couple different strategies you can use. So ways to multiply. So these are the different strategies. The first one is called double distributive. The next one is using a table. Then we have this one here, which is FOIL. Now, it has been my understanding that some of the high school teachers don't like FOIL. Okay. However, it's the only thing I can remember from taking Algebra 1 myself. So I know that it is a good strategy for being able to remember things. Okay. So I'm going to teach it. You can definitely use it. When you get further on into a different class, they may tell you don't say that. Okay. But myself and the other Algebra 1 teachers all agreed it's a perfectly fine strategy. And again, it's the only one I can remember. So obviously it sticks in your head and lasts for a very long time. And then the other one is by times try. So that would be like a binomial times a trinomial. And when we do that, we can do that vertically. Okay, so those are the 4 methods that we are going to look at for multiplying our polynomials. So the first method, which is double distributive. So I'm going to have something like this. I have x plus 8 and I have x plus 2. Okay, so the first thing I want you to visualize is that these are touching, and touching means, if you can see my finger, my shadow puppets here, right? Oh no. Touching. If you had me before for class, you know this is what I always say. Touching means, sure, I'll answer the question. Touching means multiply. It means to multiply. So these are touching, it means to multiply. Now, if you could visualize having a coefficient out here, outside of this parenthesis, and it was touching the parenthesis, then we, in a normal problem, would think about distributing it. So this is essentially the same thing, except we're going to do a double distributive because there are 2 terms there in the first parenthesis. So the first term, which is x, I'm going to distribute to each term inside the second parenthesis. So when I do that, I have x times x, which makes x squared. And I have x times 2, which makes 2x. And then I'm going to double distribute this second term into the second parenthesis, both terms. I'm going to put it down here. When I do that, I have 8 times x, which makes 8x, and I have 8 times 2, which makes 16. At this point in time, I'm going to combine like terms. So I have x squared plus 10x plus 16. There you have it, double distributive. There's not a lot of work you need to show on this. The jumpy arrows are not technically required. However, they help you to keep track of the problem and what numbers you have used. So even though it's not necessarily a requirement right now, I'm going to highly suggest you think about using them because I think it's going to help you. Okay, so our next one is going to be our table. Now, depending on who your 4th or 5th grade teacher was, someone may have taught you generic area model. Does anybody recall this? Holy
I remember the name, but not how you do it.
Okay, so like I told the other period, I feel like I'm going to have to contact some of your teachers because y'all should know this. So basically a generic area is taking a rectangle or a square and using it for multiplication, because any multiplication problem can be represented as a square or a rectangle, as an array. So anyways, we're going to do this same problem up above, but using generic area, so that way we can see the comparison between the two. So in order to do generic area, it doesn't matter if you use a straight edge right now. I'm doing it because I just want it to look neat and whatnot, but I don't care if yours is super neat or not. It's fine. So essentially, when I looked at this, I have 1, 2, 3, 4 terms. So I want to make sure I have 4 boxes down here. That's the first thing. Then from there, what I'm going to do is I'm going to take my first binomial and I'm going to write it in what we would say like expanded form. So this is going to be x plus 8. And then I'm going to take my second binomial and I'm going to write it in expanded form, x plus 2. So what's going to take place is where these terms meet each other inside a box, I'm going to put the product of the terms there. So like x and x, they meet in this box. So I'm going to put the product here. So x and x meet, it makes x squared. X and 8 meet, it makes 8x. X and 2 meet, it makes 2x, and 8 and 2 meet, and it makes 16. So you can see that this is a very easy like organizational strategy to keep your things nice and neat. If we look here, these are going to be the like terms that I can combine to make sure it's fully simplified. So this leaves me with x squared plus 10x plus 16. Okay, same answer as before, just a different strategy for organizing our work. Okay, our next example. Our next example is going to be FOIL. Sorry, I'm trying to get situated so you can see what I'm doing here. FOIL. And we're going to do that with x minus 5 and x plus 1. Okay, so FOIL, the reason I remember it is because it is an acronym, meaning that each letter stands for something that you're going to do, right? It stands for a name. So the first letter there is F, and F stands for first. And so what that means is I'm going to multiply the first term in each parenthesis. So that would be x times x. Then I have O. O stands for outer. That means I'm going to multiply the outer terms. Next, I have inner. I'm going to multiply the inner terms. And then I have L, which stands for last, which means I'm multiplying the last terms. So again, FOIL, first, outer, inner, last. It is an acronym to help you remember that you have multiplied everything, right? Because it's going to be really easy to skip over something. So first term times first term. That's x times x, which makes x squared. Inner, oh, I'm sorry, outer, x times 1, which makes x. Inner, negative 5 times x makes negative 5x. My last, negative 5 times negative 1 makes negative 5. These are like terms, so x squared minus 4x minus 5. Now, if you take a look at this, you can see that FOIL is the same thing as double distributive. You're doing the exact same thing. Except again, FOIL provides you with an acronym in order for you to remember that you've multiplied everything you need to. Okay, but essentially FOIL and double distributive are the exact same methods. Okay, our last one is bi times tri vertically. Oh. This is a bi times tri vertically. And I'm going to do x plus 5 times x squared minus 3x minus 2. So this is using this traditional algorithm of multiplying multi-digit numbers. I'm going to go ahead and put my trinomial on top. I'm going to be stacking these like I would with a traditional multiplication algorithm. So I have x squared minus 3x minus 2. Then I'm going to go ahead and take my bi, and I'm going to put it on the bottom, which is x plus 5. And then I'm going to multiply these. Now, if you put your multiplication sign like I just did, that may end up confusing you. So you probably want to like differentiate that that's not a variable in your problem. Okay, so then from here, I'm going to go about doing the same steps as the standard algorithm. So 5 times negative 2 makes negative 10. 5 times negative 3x makes negative 15x. 5 times x squared makes 5x squared. Now, in doing the standard algorithm, you all were told, put a placeholder here. Okay, hopefully you know why you put the placeholder there. You're doing that because in traditional multiplication, you're changing the place value spot. Regardless, we're changing here to the x, so I have x times negative 2, which makes negative 2x. I have x times negative 3x, which makes negative 3x squared. And I have x times x squared, which makes x cubed. Now, because I added that placeholder, everything is lined up in matching like terms, so I can easily combine it. So I have a negative 10. This makes negative 17x. This here would make 2x squared. And then this is x cubed. So that is a bi times a tri vertically. You could technically use this for some other things. I would say, though, that the more like a try times a try, you have more terms and it's going to be more complicated. So those are the 4 methods for multiplying polynomials, and you need to be comfortable with all 4 of them.